As you can see here, the stack of three papers and the singular paper hit the ground at different times. You may ask, shouldn't they hit the ground at the same time because gravity has the same acceleration on all objects? Well, they hit the ground at two different times because they have two opposing forces acting on them: the downward forcing weight and the upward forcing air friction. Their respective weights cause them each to have a certain number of downward forcing newtons so that they can accelerate at 9.8 meters per second squared. But the air friction but with the air friction they are slowed down. The stack of papers now only has 2.5 newtons of force downwards, and the single paper only has zero point 0.5 newtons of force downwards, cutting its acceleration in half. Therefore, the stack of papers will have a much greater acceleration and speed in falling down compared to the single sheet of paper. This is why objects with a larger weight have an easier time reaching the ground compared to a lightweight object. There is still acceleration between the two objects, but the stack of papers will reach a higher terminal velocity due to the fact that it has more mass. Now we have a scenario where there is no air. The objects reach the ground at the same time in the end, as there is no secondary force acting on them apart from their weight, and also due to the fact that they have the same gravitational pull and force. In this scenario, they both have an acceleration of 9.8 meters per second squared.